The objective of this project is to build a basic real-time system on an Arduino Uno board. The second one is to use the knowledge of preemptive periodic scheduling in real-time system from previous lab. The last one is to demonstrate the effective project management skills in solving given problems.
In this project, we have used a total of 10 equipments and tools. The first one is PC workstation, Arduino IDE software, Arduino Uno board, 100k ohm potentiometer, 10k ohm resistor, LDR sensor, 2 green LEDs, 2 yellow LEDs, a breadboard, and jumper wire. Introduction. This basic project demonstrates how to use Arduino with a real-time system. The goal of the project is to demonstrate how Arduino may be used in conjunction with a real-time operating system, as well as how to use hardware and software components. Arduino is an open-source platform used for constructing and programming of electronics. For software development, a modified version of Arduino dubbed Arte was employed.
This project is based on this figure 1, where students were tasked to create a real-time system on Arduino Uno, where the green and yellow LED is manipulated by the voltage controlled by a variable resistor and a LDR sensor. The voltage value controlled by the variable resistor and LDR sensor will be displayed on a serial monitor from the Arduino IDE.
Here is our simulation in Proteus. So here, as you can see, we use one Arduino Uno, torch_LDR or LDR sensor, 100k ohm of potentiometer, 4 resistors, which are R1, R2, R3, and R4. All 4 of resistors, we use the value of 10k. And we use 2 green LEDs and 2 yellow LEDs. All these are connected to the ground.
So here is the source code. We have 2 loops based on computation time, which is 1000 and 1500. So for the loop 1, same goes to the loop 2, but we use different type of equipment, which is for the loop 1, we use for LDR sensor, and the loop 2 is for variable resistor, which is potentiometer. So for the loop 1, if the loop 1 inside the loop 1 the voltage is 2.5 until 3.3, it will show yellow off but the green on. If else if the voltage is 3.3 and above, the LED will show on and the LED will off. So else if the voltage is 2.5 and below, the both LED will off. So it will print the start time as the print time 1, base time 200, and the end time also will print time 1, base time 200. Same goes to loop 2. But we change the period from 5000 to 7000 for loop 2. For loop 1 is 5000. So next, here is the result when we our output when we do the simulation using the IDE. Variable resistor, if below 2.5, will show both LED off. If 2.5 voltage until 3.3 will show green LED on and yellow LED off. So if the LDR sensor and variable resistor is 3.3 and above, so the result will show LED yellow on, green LED green off. So here is the serial monitor when we construct the circuit.
In conclusion, we look at how an Arduino Uno works, both the hardware and software, from the components on the hardware to knowing how to write code in the software IDE, and how to combine the two to create our own project. We introduce Arte, a C programming language extension with a limited set of constructs for programming various elements of real-time systems. In this work, a source-to-source Arte compiler is designed and implemented, and a case study for a real onboard computer is conducted.
Okay, as for recommendation, we recommend the usage of potentiometer as the variable resistor due to its ease of use, which is you just twist it to control the voltage, compact due to its small size, and cheap compared to other variable resistors such as the rheostat. Next, if possible, conduct the project in a dimly lit room so that the LDR is easier to be controlled, as the greater the light intensity towards the LDR, the lesser the resistance value of said LDR. And then to apply light towards an LDR sensor, a torchlight directed towards the LDR is more than sufficient.